You can read this one. This one is just structure. You can also read, okay, how the bacterial structure looks like. And then these are all the the class of compounds, okay, and then the functional group, and what are the names, okay, that you can also read. Not so important, but just for your knowledge only. And then this one is actually analysis of the cell component, which vary among the different mechanisms, and this will help us seeing metal uptake by different mechanisms. Okay, so we have the processes, okay, that is called as complexation, chelation, chelation, coordination, ion exchange, precipitation, and reduction. So you can read this by yourself. Okay, and then there's actually the types of biomass. Okay, the bacteria and the algae, and so the type of microorganism that can be used, okay, to absorb the heavy metal in the form of copper, nickel, chromium, lead or plumbum, okay, and then nickel, zinc, cadmium, and so on and so forth. So the removal efficiency, when we talk about the how efficient the heavy metal can be removed from the system, is in the form of percentage, milligram per gram. For live biomass and the dead biomass, you can compare it here. Okay, if for example, I just give you one example, copper 2, okay, which have the initial concentration of 5, okay, ppm, and at pH 7, the live biomass, okay, of Bacillus sphaericus can absorb 63.25%, or can remove 63.25% of copper 2 at pH 7 from the system. While the dead biomass, okay, of this Bacillus sphaericus, for instance, the dead biomass I mentioned just is exudates here, the outer exudates, or if you can see back the slide just now, you can refer later, okay. So the dead biomass is about 82.2%, so much higher than the living biomass. Okay? And normally it's like that. Okay? Dead biomass will be more absorptive in comparison to the live biomass. Okay? But okay, this one is just again, I think the repetition. Okay, the solid structure mechanism can trap heavy metal and subsequently sort them into binding sites and so on. Okay, this one you can read yourself. Chelation also you can. Okay, chelation is basically you add on EDTA, okay, EDTA to the metal ion, and eventually the metal ion will be taken up by the EDTA, and it will be in the inner part of the cell. And this one had been done before in one of my experiments, where I put EDTA in order to ensure that the ion still present and still bioavailable for my microalgae to grow, and so my beneficial microbes to grow. Okay. Okay, and then next. Ion exchange, okay, this one you can just read yourself, not so difficult. Precipitation is precipitated within the cell. The reduction, okay, is reduction from the higher valence to the low valence. For instance, for this one, chromium 6, okay, can be reduced to chromium 3 by this particular Streptomyces pilosus cell, okay, right? And then metal treatment by hydroxide precipitation. This one is chemical, which is hydroxide. You can read it as well. Okay. I just want to talk about the bioaccumulation. So bioaccumulation is actually the build-up of the chemical in living organism. I think if you take Bio 400 during your first year, you will learn about this as well. Okay. So what happened is, okay, how these particular elements, okay, or the metal ions can accumulate within a cell. Okay. First, when the small fish, okay, take up this particular heavy metals, it will be in the form of ppm. Okay, and then after that, this big fish is eating these particular small fishes, and the heavy metal will accumulate more within the system, and after some time will start to getting increased. And when we human consume this particular bigger fish, okay, and eventually the human will get the disease from this particular bioaccumulation of the heavy metals, because the heavy metal has been accumulated more within the bigger fish, because when more smaller fish are being eaten by the bigger fish, so this particular bigger fish will have more chemicals, okay, within the system, and which will lead to death. Okay? All right. Okay, and then this one, biochemistry, I say you can read just a simple definition are all there. And then this one, as I mentioned to you, okay, the biochemistry. And lastly, the following factors affect bioabsorption process. Okay, so bioabsorption process will be affected by number one is temperature. Temperature not to influence the bioabsorption in the range of 20 to 35 degree, but if more than that, it will start to become a severe problem. pH seems to be most important parameter in bioabsorption. It affects the solution chemistry of chemical, the metals, okay? The activity of the functional groups in the biomass and also the composition of the metallic ion. Okay, and then okay, you can read this one advantages and also disadvantages of this particular bioabsorption over the conventional treatment methods. And I have finally there is a question for you for this one. Okay, so please read by yourself. Okay, thank you very much for your attention for this particular first slide, and now we move on to the next slide. Okay.